So this section is a little bit about how weird water is. Water is the most important and the most common liquid on Earth. Most of the things that you can name as liquids are actually aqueous solutions, right? Some liquids that are not water that you might be familiar with would be things like acetone, isopropyl alcohol, gasoline, those sorts of things. But most everything else is actually, milk, soda, orange juice, those are all aqueous solutions. Water has a very low molar mass, and yet it's a liquid at room temperature. We looked at that when we looked at hydrogen bonding. It's the main solvent in living organisms and in the environment. It has a very high specific heat capacity compared to other substances, so it moderates climates. And it expands upon freezing, which most things do not do. Here we have a head of lettuce that's all nice and beautiful, and if that's in the part of your refrigerator that's a little too cold and it freezes, it's going to look like this. Because as the water freezes, it expands and it breaks the cell walls, and your lettuce turns to mush when it melts. Here's a more detailed comparison of boiling point versus period for several different families. And so here for group 4, these are going to be nonpolar substances, and we see a nice linear trend, and the boiling point rises as the period increases because of increased dispersion forces. You get into group 5, 6, and 7, and now you have polar substances because there's a lone pair on the central atom. So these have higher boiling points, but we see, fairly nice trends here. But when we look at ammonia, hydrogen fluoride, and water, they are unusually high in their boiling point compared to their companions here.
Because they're polar.
Well, they're polar, but what else do they have? Hydrogen bonding. ET phone home, right? Fluorine, oxygen, or nitrogen. Here you've got oxygen, here you got fluorine, here you got nitrogen bonded to hydrogen. So you have super dipole-dipole forces called hydrogen bonding.
Just why it does that again?
So the reason that these intermolecular forces are extra strong is because the dipole moment in these molecules is larger due to the difference in electronegativity, and the atoms are small, which means that they can get very close to each other. And so it basically comes down to Coulomb's law, where the energy is proportional to Q1, Q2 over R. So we're not looking at ions here, but we're looking at a dipole moment where we have separation of charges. And so the larger separation of charge will give you a stronger attraction. And a shorter distance between the two will give you a stronger attraction. And so these are the 3 that have the most. Any other questions? Water pollution is a problem because we need water to live. There are 2 types of, and I'm not going to test you on this, there are 2 basic types of water pollution. There's biological contamination and chemical contamination. Biological contamination would be microorganisms, dysentery, cholera, etc. And these usually get into drinking water from animal or human waste. You can treat this chemically. Things like bleach kills a lot of microorganisms. Boiling the water will kill a lot of microorganisms. So you can treat that without too much difficulty. Chemical contaminants, though, a lot of them are non-volatile, meaning they're not going to quickly evaporate if you boiled them. They're not alive, so you can't kill them. And so if you boil the water trying to get rid of chemical contaminants, not only does it not get rid of the contaminants, but if you boil it for a long time, you've reduced the water volume and you actually concentrate the chemical contaminants, so that's not so good. These come from industrial and household dumping, from pesticide use, from fertilizer use. Put fertilizer on your lawn. The lawn uses some of that, but some of it gets washed away with rain or irrigation water and gets down into the water table.